Right, I have a conducting rod. You can think of it just being like a copper rod, and I've connected it to a battery. So the left end of the rod is at the same potential as the positive terminal of the battery, and the right end of the rod is the same potential as the negative terminal of the battery. The first question we want to think about is there going to be an electric field in that wire? Now, previously we had talked about conductors that are in electrostatic equilibrium. And if that were the case, then no, there would be no electric field in the conductor. Here, we are putting energy into the system through the battery such that the left end is always held at some positive voltage relative to the right end. So there's a continual input of energy, and it is not a case of electrostatic equilibrium. There will be an electric field inside the wire. So let us answer some other questions. What direction is that electric field going to point? Well, the electric field points from higher potential to lower potential. So inside my conductor, I'm going to draw a few electric field lines. And that electric field is going to point from the positive end to the negative end. So it points to lower electric potential. So the electric field points from higher potential to lower potential. What direction are electrons going to flow in this circuit? Well, the electrons are going to be repelled from the negative terminal of the battery and attracted to the positive terminal of the battery. So this would be the direction of electron flow. So the electrons flow from negative terminal to positive terminal. So that is the actual charge carriers that are in a conductor. We sometimes might call this the physical current. So the physical current is going to go through the conductor from the right end to the left end. Now, everything for our conventions for circuits are set up for hypothetical positive charge carriers. So conventional current would be made up of positive charge carriers that would be repelled from the positive terminal and attracted to the negative terminal. So the direction of conventional current is that. So conventional current will flow from the positive terminal to the negative terminal. Where we're at in the class right now, there are no effects that depend upon whether it is hypothetical charge carriers that would flow through this conductor from left to right that are positively charged, or the actual charge carriers, which are electrons, negatively charged, flowing through the conductor from right to left. Both of those are going to give us all of the same properties. Once we learn a bit about magnetic fields, we're going to learn about something called the Hall effect and how we can distinguish between the sign of the charge carrier and a conductor. But up until that point, there's no difference between the conventional current going left to right or the physical current going right to left. They're all going to give the same results in terms of physics.